So I am Professor of Computer Science at the Royal Institute of Technology in Stockholm, and I do research in robotics. Well, I think that first of all, I have an amazing husband. And I do get lots of help from my family. But I think that the important thing is that not all of the functions actually are active at the same time. So I do have a good way of balancing things and concentrating or focusing on those that are most important at a time. And I think that it's like that for everybody, doing the things that are like, you know, first at the list. So there are, if I'm not mistaken, 2 projects left from FP7, and we have 4 new projects from Horizon 2020, and there are a couple of national projects that are going on. But I have an amazing group with lots of senior people that are active or actively involved in projects, so they help a lot. So I would say 8 to 10 projects. I hope all of them, but to be realistic, I think that most of these projects are actually too short to make a significant impact. So most of the projects we get from EU are only 4 years, in the best case 3 to 4 years, and that's also the case with national projects. And it's not always that easy to build on the previous project and continue collaboration with the same partners. So if I'm to be a bit critical about the financing situation, I think that it would be better if projects are about 10 years long. I think that, you know, making an impact takes a long time. But I think that the collaborative projects, so projects that we have with other EU universities, where there are like, you know, 6 to 8 universities involved, these have a tendency to have the largest impact because there are many people involved, and then they can, even after the project has finished, they can continue on the topic in different national and international projects. So right now I have an ERC starting grant, and I like that very much because it's focused in the group. Many of the collaborative projects also have the, I would say, an administrative burden of basically traveling a lot and collaborating a lot, which is really nice, but sometimes takes off the focus from pure research. So my ERC grant, which is on then studying human grasping and designing new future robotic hands, that one I like the most. We do publish almost everything we do in open access. The reason is also that the university I'm affiliated with, KTH in Stockholm, also has that as a, let's say, one of the focuses, having everybody publishing open access. I think it's good. Primarily not solely for the purpose of having the work visible in the robotics community, but also having it visible outside the robotics community. I think that robotics today is also an area that has a great potential of, let's say, starting collaborations or making impact in other areas, such as, for example, medical field. Or education, for example. So I think that people that are not directly from our community also have then easier time to download our results and our articles and looking into what we are currently doing. So I think that open access is definitely very important. In the area of object grasping and manipulation, I think that lots of things have been done, and people have been doing research in this area for a long time. Hands have been the focus of research even before mobility, for example, existed. But I would say that we do not see the results we hoped we would see, like maybe 20 years ago. And the reason is that we have realized that building robotic hands or hands for robots is actually a very difficult task. One reason is the dexterity, the number of degrees of freedom. But even bigger problem is actually putting sensing on hands. So having the same type of sensing, for example, humans have, like being able to sense contact, being able to sense temperature. And we have not come as far as we have hoped. And then also integrating grasping with perception, so understanding what the robot is supposed to grasp and how, and what is the material the object is made of. So for example, grasping a glass from a table or a cookie is a very different thing and requires a very different type of sensory feedback for the hand to be equipped with. So I think that that's one of the big problems that we see today in robotics, that we do not have the development in this area at the level where we would like it to be. And I think that what was visible also during this latest ICRA conference, International Conference on Robotics and Automation, one of the challenges, the Amazon challenge, was a rather simple challenge. There was a shelf filled with objects, and the robot was just supposed to empty the shelf, something that we humans, I think, can even do blindly. But there are very few successful teams, and I think that it just demonstrates that, you know, on one side we have science, and on one side we have the demonstration of science, and that just shows how having robots involved in real natural environments, dealing with everyday objects, is actually a very, very difficult task. We do have, especially in EU projects, we do collaborate lots of with psychologists, for example, behavioral scientists, neurologists, neuroscientists. And the reason is that we would like robots or robotic systems, artificial systems in general, to be partially inspired by the way humans do things. The reason for that is not necessarily that we want to mimic human system, but we need to also understand human system if the robot or robots in the future are supposed to interact with humans in their natural settings. So I think that there is a misconception from people outside our community that we just want to mimic biological systems to some extent, but it's also very important for us to understand those systems in order to make robots more adaptable to human environments. So more specifically at KTH, we are organized in different faculties. So we have faculty of or departments, let's say, and above departments there are also schools. We have School of Computer Science, School of Electrical Engineering, and so on. But we also have a, if I can call them like that, umbrella organizations, which are what we call platforms. And these platforms are more, let's say, concentrated on very specific scientific areas, such as platform on material science or ICT, information communication and technology platform, and so on. And then we have scientists from different schools contributing with their knowledge to that specific area. So I think, well, in order to promote the interdisciplinarity, it actually needs to be organized in some way. So locally at universities, it can be then organized in that way, so umbrella organizations. But I think that EU is also doing very much in terms of announcing, let's say, very specific areas for projects where there is a need for scientists from different scientific areas or areas of science to contribute. So, for example, we talk about the societal challenges, and we don't necessarily talk about robotics, but robotics technology can contribute to very many, let's say, scientific or societal challenges by contributing, for example, to agriculture, by contributing to education, by contributing to, let's say, areas of medicine and so on. So I think that the responsibility is partially on the financing bodies like EU to come up with the right organization for the announcements of the calls for projects, and at the universities to stimulate the collaboration through then different types of umbrella organizations. I think that robotics is an area where young people with lots of different interests can find themselves. So if they like to build things mechanically, they can build robots, they can equip them with different types of sensors, and they can also program those robots. So I think that for lots of young people, it's something that they can see moving, and that they can design things dependent on what they like. And also I think that Hollywood movies can be a source of inspiration from the perspective of giving ideas of what kind of robots they can build, but mostly in terms of what kind of behaviors or selves those robots can have. So building nice robots, basically. I do agree that well, lots of people that are not doing research in robotics and do not understand how far science has come have partially misconception about the research that is being done because of Hollywood movies. So I think that it is our responsibilities, us as researchers, to inform the society about the research that we are doing, but also we cannot hide the fact that to some extent the things that we are developing can be dangerous. But I think that that's not only the case with robotics, it's the case with lots of other areas where we develop new medicine, where we develop new weapons and things like that. So I think that we need to be better in communicating about the results of our research. So open access is one way of doing that. But I also think that there is a responsibility from other areas. So to be more involved and talk to us, researchers in robotics, and talk about, for example, the fact that in the future, if we do have these advanced systems coexisting with humans, and we will have them, how does that affect us as humans? And we don't have that knowledge as doing research in technical sciences. What is the effect of, let's say, human development or brain development in terms of having robots cleaning our homes, doing our beds, doing our dishes, and so on? Whether that should be psychologists or philosophers, I'm not sure. But there is very little interest, I think, as I see it, to take seriously upon that task and talk to us and really discuss about the implications of the work that we are doing. Right now, most of the researchers from that field are concentrating on, let's say, bad impact or bad influence or bad developments. And to some extent I can understand it, because we can only look back 100 years and say, okay, this is how we were affected. It's very difficult to foresee the future. But I think that right now we do have systems that we can already start to test and see how humans are affected. So, but I don't think that only roboticists can do that. It's very difficult to define the equivalence. Sometimes the question is whether robots will be as intelligent as humans, and that's equally difficult to say what's intelligence. What do we mean by intelligence? And then everybody says, okay, can a robot be smarter than a human? And then I say, well, I mean, what do you mean by smarter? Because already today we do have all the computers, right, that can store more data and access data very fast, or faster than we can. They can remember more, they can do computations much faster than we can. Is that intelligence? So I think that in terms of having robots that are more intelligent than humans, we will need to define the intelligence, and I don't think that that's so easy to do. But I definitely think that we will have systems that will do things more precise than we do them. They will not get as tired as we get, and maybe they will have easier time on making decisions which are not based on emotions, which may in some situations be better. Like, for example, if we have self-driving buses, or if we have a robot drive a bus that doesn't get tired, that doesn't get warm in 40 degrees or something like that, not getting irritated and nervous and so on. This is not about intelligence, but it's about taking a job that is, let's say, dull or dangerous or dirty for a human. Partially it might be social and cultural, but it's also very dependent on the financing situation, who is financing and how is the research financed in different areas of the world. I think that in Asia it's much, let's say, it's easier to see something that moves as being alive, and have and develop emotions and be free about that when it comes to robots. And in Europe, I think we are looking much more into function. We want robots to, let's say, clean the floors and things like that. So we are willing to pay for things that fulfill a certain function. And I think it's very natural, and I think it's actually also very good that the focus is different in different parts of the world, because there is also lots of collaboration going between the countries, and the aspect of cultural difference, not only how we live our lives, but also what we think we would like robots to do for us, also has an implication of what kind of ideas we can pursue as researchers. So I think that yes, there is difference, but difference is good. So challenges in terms of, let's say, somebody doing research work in general. When you start as a PhD student, you're on your own. You sit in your room and you program, and most of the things are fun. But the older you get in your career, your function changes. You're not a researcher only, but you need to administer things. You need to lead bigger projects. You have responsibility for the lab. And also, which I think is very important, you have a completely different role in terms of informing the society about the research that you're doing. So you have the responsibility as a researcher or as responsible for a bigger group, right? And I think that none of these things we are really trained for when we come out from university. So you just learn it, and it is a challenge. Some people like it, some people don't. So I think that when I think about challenges, those challenges are not solely scientific, but the challenges are in terms managing like larger group or managing collaborative projects. And in terms of what I would like to work on, there is lots of interest, especially in Sweden, in using robotics technology to help people with special needs. And I think that that's an area where we can do today very, very little, because we just, there is, on the user side, there are so big variations in what people need. So it's not so very easy to say, okay, we will just develop one robot that cleans floors, because deploying that robot in somebody's home that maybe a person cannot walk, or a person walks in a very special way or something like that, there might be very special needs. So I think that developing or deploying robotic technologies for people that have special needs, I think that that's really a challenge, and that's a project I would like to work on. Oh wow! I think it's different in different, or it has been different since the beginning of my research. I think in the beginning it's very natural that you have your supervisor affecting you a lot, because they tell you what to do, or they tell you what not to do, and in general you either have you may have a very good relationship to your supervisor, but out of very kind of like stressful relationship from both sides. It can also be like having a relationship with father or mother, you know best, and they don't. So I think in the beginning the supervisor is very, very important, and it has been like that in my case. But then if you set out and have lots of collaborations and build a big group, now I think I have 11 or 12 PhD students, you're very affected by them. And not only by the research that they are doing and the opinions that they have, but also very much by the private situations that they have, and their needs, and trying to have a well-working group with 12 very different entities. So I think that you're very much affected, so to speak, by the people you work with. And yeah. Yeah, very often. Maybe not every day, but fashion is still in my life. I do like to sew clothes. And every time I travel for a conference or something like that, instead of souvenirs, I buy myself fabrics. So I usually say that I don't have a shrink, but I have my sewing machine. So every time when I feel very stressed, that's a way of actually forgetting a job and doing something that I like. I think that it gave the way with sewing, like with research, you need to be very creative, right? Because there are very many people doing the same thing. And if you want to be different, do something on your own, you need to sit down and you really need to think. You need to see what other people have done, how they have done it, and you want to do something different. So I think that there are similarities between the areas, but when it comes to mathematics and when it comes to robotics, when it comes to science in general, you need to be very, very structured. You need to make a plan, and you need to follow the plan, and when things don't go as you want them to go, you still need to find the energy and redo things from the beginning. And it's a little bit like that with sewing also. Sometimes you need to sit down, you need to make a pattern, and you need to be very structured, and then when it doesn't become what you wanted at the end, you need to just do everything from the beginning. Absolutely. I think that today people don't really, or young people sometimes don't understand that mathematics and physics are very important, and for computer science or electrical engineering and so on. So I think that good mathematical skills are extremely important for the research that we are doing. And I also think that you cannot just, okay, there are maybe some people that are, natural born mathematicians, but everything is about training. So in order to be or to become good in something, you really need to give it time. So you need to sit down and you need to do things. And by doing and learning, you do them better. And so yes, I mean, you can start with a certain set of skills and you can improve them by working hard. It's a tough job, but somebody needs to do it. I think that it's a scary thing. So it's less than a year from now. We'll have lots of people running around in Stockholm. And even the scarier thing was that we realized that we are also in May next year. Stockholm is also the host for the Eurovision Song Contest. What was even scarier, because we thought that it was going to be the same week and we wouldn't get any hotels and things like that. So you learn a lot. I mean, you need to be on time in terms of planning for the hotels. You need to be on time planning how to find the sponsors for the conference and so on. And especially now with ICRA 2016, this is the first year that we will also have relation to the new publications, IEEE transactions letters. And that also puts some extra burden on the organization. But I have a fantastic team, especially in program chairs. Antonio Bicchi and Alessandro De Luca are fantastic and very experienced, have been in the field for a longer time than I did. So yeah, there are lots of help. I think that some conferences, have a tendency to be remembered for bad things, like not enough coffee and not enough cookies. I hope that that will not be the case in Stockholm. So I'll do my best that we have enough food. But what I would like people to remember ICRA in Stockholm for is for the city itself, right? So it's May, it's going to be really long days in Sweden and hopefully nice weather. So I hope that people will learn to also, like Stockholm. It's called Venice of the North because the city is on so many islands. And we are really trying to organize everything in the city. So I hope that people will partially remember the city, but also we are trying to organize the program so that the science comes to its best. So in collaboration with Professor Bruno Siciliano, who is editing the Handbook of Robotics, we'll try to also have very specialized tutorials on specific topics that have been published in the book and that hasn't been organized so far on any of the ICRA. So I hope that people will like that. Oh wow! That also changes from time to time, but somebody that I met very early in my career and somebody that impressed me was a lot and still does is Rózsina Bajsi. Not because she's a female researcher, but because she is somebody with lots of energy. And she always says the right things. And a couple of years ago, one of the ICRA or IRISes, she stood up in front of all the attendees, and she said, "You probably don't know. You young people probably don't know who I am, but I'm standing here," and so on. I think that she's one of my favorites because I think that she's very realistic. She knows what's important, and she never runs from difficult problems. So definitely somebody that I respect a lot. And then for 4 others, I won't say anything apart that I hope that some of my PhD students definitely deserve places of those 4 places. I won't name them, but those that do their PhD thesis on time. So when they listen to this, if you did your PhD thesis on time, you're one of those 4. All the robots that have been portrayed in movies that are not villains. And there are a couple of them, not too many. You know, if you go back to the Star Wars movies, there are a couple of really nice robots there. I mean, both of the R2D2 and 3CPO are nice, and I think that 3CPO because he's very elegant. So that's the reason.
Okay.
He's a gentleman. I will say that what I really like is the House of Dior. So if I would go to the not the designer they have now, but the one that was there previously, it used to be my favorite. I won't say his name, or maybe I should. It was Galliano, but then he did some not so politically nice things. So yeah, I didn't like that very much. But then House of Dior, I would still keep it place number 1.